how do we then introduce time? How do we do it? Any suggestions? Can anyone recall what direction we go in from here? Excellent. Okay, so this guy here, V, right? Just like we noticed over here, maybe I shouldn't rub that off just yet, okay? V is dx on dt. So time doesn't look like it's here, but it really is, okay? So I'm going to say dx on dt equals this, okay, by definition, okay? Now, what am I trying to get to? I'm trying to make x the subject in terms of t. That's good so far. I've got lots of t's. I've got an x there, okay? How do I get there? What should I do? Now I'm going to have to, clearly I'm going to have to integrate somewhere, right? But I can't integrate with this with respect to time. Why can't I integrate it with respect to time? It's not in terms of time, right? But I can integrate it with respect to x, right? So that means this guy needs to be on the bottom. I'm trying to explain why. It's not arbitrary that we just flip this guy over. The reason we flip him is because we need to integrate with respect to the denominator, okay? So you flip the left, that means you flip the right, okay? All right, now I can integrate. If I integrate this side with respect to x, what happens? You just get time. Okay? Just like if you integrated dy on dx with respect to x, you would get y plus a constant, of course. Okay? So I've got time over there. That's good. Now you look at this guy and you think, Now he's not a standard form. He's not. But he's close enough to one that we can work it out. The question is, how do you tease it out of there? Now, what do we know about this, right? Because this point is really important. This is the point in the exam where you're like, oh, what do I do? And I'm rushed, right? What things can you tell me about this that are obvious? I'm trying to lead us in a direction to work out what standard form I should go toward. I could choose a substitution, couldn't I? What would you choose, by the way? You could say let u equal e to the negative x plus 1. Let's just try that. Let's see what happens. Now, if I'm going to use this substitution, right, then I'm going to need to know what du is so I can get rid of the dx. What is it? It's negative e to the negative x. Now we have a problem. This is a problem, right? Because this is nowhere in here, right? At least not yet, right? So I can't, this is not a suitable substitution. Substitution was a good idea though. What else can we try? Yeah, I'm going to need to multiply by something, but the question is what and why, okay? What I see here is that, I know this is really obvious, but it's a fraction. It's a fraction, right? It's a rational function of some kind, okay? Now, when I see fractions, what kinds of integrands, right, what do I get out the end after I integrate a fraction? For instance, here's a fraction, right? You know what that is. If you integrate that, you'll get a log, won't you? Right? But you only get a log because this guy has a special relationship to this guy. Namely, it's the derivative, right? Now, this does not look like the derivative of this to me. But we can make it. We can. Because e to the x is special and cool. I don't want this one, okay? We're going to multiply by something, okay? Now, Elian, would you like to give a suggestion?
E to the x.
E to the x. Let's multiply by e to the x on e to the x. Okay, what will happen? Okay, so here's my original. Okay, now e to the x is special because when you multiply it through, what are you going to get on your numerator? E to the x. Index laws, what's going to happen to these two? 1. And then you've got an e to the x on the bottom. And there's my f dash on f. There you go. There's the log. Okay. Now I don't think that is at all obvious from here, unless you've done this exact question before. You're like, I've seen this. Okay. But when you look at this and you're like, it doesn't go in a helpful direction, and it's a fraction, that kind of gives you a signal. Okay. Right. Need some more room. So we decided this substitution was bogus. Get rid of him. We said it was a log function, right? So this is time equals log of such. You okay with that? That's a bit naughty, sorry. I'll fix it up in retrospect. There you go. Okay. What do I do with this constant? I go back to the initial. See, there's so little information, right? That you're like, well, I don't have anywhere else to go. So I've got a t and I've got an x when t equals 0, x equals 0. That's where I begin at the origin, okay? So let's give it a whirl. 0 equals log of 1 plus e to the power of 0 plus my constant. What's this going to be? This is just log 2. I'll kick him over the other side. I might as well. Negative log 2. Okay, I could write him as log a half, but as you'll see in a second, there's not that much point. I'm going to bring my constant back into my time equation. Minus log 2. Okay, now let's just pause. You have to do this at the end of every major stage. Like, oh cool, I finished the integration. Where am I headed again? What am I heading toward? I need x as a function of time. So all I need to do here is change the subject. That's it. I think we've done most of the legwork, okay? So what can I do here that will make it easier to tease out x on its own? I've got some log laws I can take advantage of here, right? Namely, when you subtract logs, that means division, yeah? So you've got 1 plus e to the x divided by 2. That's what that minus means, okay? That's time, okay? Suggestions? Write it as an additional equation because it's a log equation right now. So I'll go e to the power of t equals. Yes. Okay. Let's shuffle. Minus 1. Okay. Now what? I'm almost there. Take logs. You have to, of course, because we undid the logs, right? So you've got to go back. You've got to go back. What do you got here? X equals log of. Full stop. Okay. So it's a fair bit of work. That's why this is a last question type question. Okay. But I think the bottlenecks are kind of like, well, let's see. Can you remember how to use this thing? Okay. Can you make sure that you're careful in evaluating your constants? And then I think the other hardest part was here, dealing with this gross looking integral. Okay. But now that you've seen it, it won't be so gross next time. Okay.